Hi, I'm Alec, and this is a 360 panoramic camera. So it works by taking an object, and the light bounces off this conical mirror into the Logitech C270 webcam, and that's how you get a 360 image. This mirror right here is only 45 degrees, so it can see about this high, which is perfect for mounting underneath your robots for robotic applications. If you use a ball bearing or any spherical kind of mirror, you're able to get a much larger image. And right here we can see the de-warped image. So as I move the apple around the camera, you can see it show up in the de-warped image on the top and on the radar map in the bottom. Okay, let's get right into the code. So the first thing you're going to need to do is copy the code from my GitHub. So you do that by typing in git clone and then this URL right here. However, I've already got it downloaded, so we're going to skip this step, or I'm going to skip this step. And so then all you have to do is run python visiontester.py. It's going to take a quick second. And as you can see right here, we've got the de-warped image. So here's the red apple, and as I move it around, it shows up on the de-warped display right there. And so let's go into the code a bit. So the first main file is called visiontester.py, as you can see right here. So if we take a look at that, it's a quite simple program actually. What it does is it takes in the it takes a video capture, so it takes a frame from the image, and then you run the capture that you just took into a bunch of different custom OpenCV functions that I've written. So I've written a program for calculating the direction of the apple. I've written a program for calculating or for drawing out the radar map, and I've wrote a program for de-warping the image. And we're going to go over that shortly. These variables right here are for the de-warp. So as you can see right here, there's a variable called center X and center Y. That's the center of the image captured from the camera. The radius 1 and radius 2 is the size of what you're going to de-warp. So I'm going to de-warp 5 pixels from the center of the camera to 60 pixels from the center of the camera. This WD and HD are the width of the final de-warped image and the height of the final de-warped image. As you can see, the height is simply radius 2 minus radius 1, and the width is actually just the circumference of the total image of what I'm cropping out. And then down here we've got the image size to take from the camera, and then we just calculate it into an X map and a Y map. So the way X map and Y map work is they're basically an array of values for every single pixel on the final de-warped image, and the values they hold are where to sample on the original image. And as you can see right here, I also have a custom function I built for this called warp.buildMap, where it basically takes in all these variables and generates this X map and this Y map for me. And so the reason why I do this at the beginning of the program and on the loop is because it takes quite a while to generate this, probably about 2 or 3 seconds. So yeah, and let's take a look at the next file, which will be Panoramic. This is the base of the program. And what this program does, or sorry, this function, is it takes in the center X and center Y of the screen, and it takes in the frame captured from the camera, and then returns the direction of the red object I'm tracking, in this case an apple. So as you can see right here, it's a simple algorithm. You just blur the image, you convert it to HSV, hue saturation value rather than RGB, because that's easier to, for example, I can just put in the red hue and then get the saturation value to set to only look for bright red instead of doing the whole RGB thing. And then right here is the array of the colors that we're thresholding. So it's looking for anything from this color to this color, and anything that's not in these two colors, it's going to ignore. And so it's going to make a bitmap image where everything that's within these two colors is white, everything that's not within these two colors is black. And that's this thresholded image. That's this thresholded image right here. And then down here we're just finding the contours of the thresholded image. So it's going to basically look for blobs of this red color, and then down here it's going to look for all of the biggest, the biggest red blob, and then it's going to remember, it's going to figure out what the center X right here and the center Y of this blob is. And then we just do some basic trig to calculate the polar coordinates of this apple. So what I do is I first get the vector of where the blob is in relation to the center of the screen, and then I calculate the magnitude of this, the magnitude, the distance from the center of this apple, and then I have to make a normalized vector, which is just a vector of the length of 1, and to do that I just put in Vx and Vy, which I got from up here, and then I divide it by magnitude, and it just gives me a total length of just 1. And then down here, we then find the direction with inverse cosine. And so that will give me a value from 0 to 180. And the problem is that we need 0 to 360. So what we actually do now is we figure out that if the y value of this blob that we've just detected is below the center y, then we inverse the direction. So the final direction value is a value from negative 180 to 180. And then I have a bunch of other drawing functions that you can just delete the hash to add them back into the code, and they'll do things like draw direction and whatnot onto the frame for debugging purposes. And then the next file we have is the radar. So if we look at the radar, all it really does is it just draws out a radar map based on the direction and the distance you put into it. So you can calculate the distance of the object in the camera, but my cone isn't precise enough to basically figure out the distance. The way you'd figure out the distance is figure out the thickness of the blob in pixels, and that's how you get the distance. But my cone right now is a bit inaccurate, so all I can really get is the direction. And so all it does is it loads in an image of the radar map, and then using just some cosine and sine, you basically just draw the circle of where the dot is, of where the blob is, and then you just return the final image so that you can draw it in the main vision tester program. So you can see right here we've got build map, and so build map is basically creating the map x and map y values that I told you about a little bit earlier in the tutorial. All it's really doing is basically finding polar coordinates of it goes through every single pixel in the final image, and to figure out which pixel the current pixel in the final image is going to reference in the original image, you basically convert the x in the final image to direction, and you convert the y in the final image to the magnitude. And that's basically how you go and get the value from the original image. And then down here we just do the unwarping, so we take in our x map and y map, and then we output the remapped image. So then when we go back into the vision program, you can see all the way down here, it's just running these different functions. So we've got the frame capture.read, we run the get blob angle for the direction, we put that direction into the radar map, and then down here in the warp we just put those in. And then we finally have a warp variable, which is the image of the final dewarped image. This is the radar map, and frame is still the same as always. And so then down here all we have to do is then draw out these frames. So we've got the unwarped frame that we're drawing, we've got the radar frame that we're drawing, and just for kicks I'm going to disable the frame one so you can see what the frame one looks like. And the frame one is basically just what the camera's seeing unwarped. Oh, sorry. I'm using Xserver, and if I don't run it for a specific period of time, Xserver just turns off, and then I can't run my program, but yes. And then right here you can see is the image that I'm getting from the mirror right now, and you can see my hands moving around. Here's the apple. And you can see in the top left right here how this is just the dewarped image, and then this is the unwarped image. So yep, that's how you code a dewarping image for BeagleBoard powered 360 panoramic camera.